In this video, we're going to prove some divisibility rules. The first one says, well, they all start off with, for integers a, b, and c, the following rules hold. First one, if a always divides 0, 1 always divides a, and a divides a. Well, if a divides 0, that means 0 is some integer multiple of a. And yeah, it's 0 times a. It is true. And 1 divides a implies that a is some integer multiple of 1. The answer is sure it is. It's a times 1. So yes, a does divide 0 and 1 does divide a. Does a divide a? Does a divide a? Well, if it does, that means that a is some integer multiple of a. And yes, it's 1 times a. So all of these are true. A does divide 0, 1 does divide a, and a does divide a. For the second one, it says if a divides b and c divides d, then ac divides bd. Well, a divide b means b is an integer multiple of a, say n times a. And if c divides d, that means d is an integer multiple of c. Now I see a, c, and b, d. Ooh, b and d. Let me multiply them. B times d is b, which is ma, times nc. But now I even get my ac. bd is an integer multiple of ad. That implies that ac divides bd. And of course it does. A divides b means that a goes into b n times, according to this equation. And if c divides d, that means c goes into d n times. So yes, if you have b over a and you multiply it by d over c, on one hand you get bd over ac, and on the other hand you get mn. That is, ac does go into bd. It goes in mn times. It certainly does go in. Now, the next one says that this, I guess you would call a transitive law. It says if a divides b and b in terms divides c, then a divides c. Well, proof. A divides b implies that b is an integer multiple of a. And b divides c implies that c is an integer multiple of b. Oh, I want a and c. I want to get rid of b. Well, I know that c is n times b, but b is ma. B is ma. So I get that c is mn, an integer multiple of a. This implies a divides c. Now, if a divides b, well, a goes into b n times. That's basically what it says here. And if b divides c, b goes into c n times. Well, does a go into c? Well, we know that c is b times n. And a does go into b m times. So yep, a goes into c. It goes in mn times. What I'm about to erase, that's basically high school algebra or high school arithmetic, elementary school arithmetic. Okay, so that is the transitive law. Now, the next one's a little bit interesting. I like that one. It goes on to say, if A divides B, if A divides B and B is different from 0, then the absolute value of A, get my marker working well, the absolute value of A is less than or equal to the absolute value of B. Okay. Well, we have to use what we're given to write the proof. And we're given that A divides B. So I suggest that that's the first thing that we should start with. Proof. Suppose proof. A divides B. That means that B is some multiple of A. But B is not 0. That's important. So, not just yet though. The absolute value, taking the absolute value on both sides, will preserve the equality sign. The absolute value of B is equal to the absolute value of the right side. But the absolute value of a product is the product of the absolute values. Now, B is not 0. That implies M is not 0. Because if this is not 0 and M is 0, then 0 times A can equal the non-zero number B. So M is not 0. Okay. Well, that implies the absolute value of M is not 0. That means the absolute value of M is positive. But since M is an integer, it's at least 1. Now, copying this down again, the absolute value of B is equal to the absolute value of M times the absolute value of A. But this is bigger than or equal to the absolute value of A. The absolute value of A is some number, some non-negative number. Actually, it's positive. If M is the absolute value of M is 1, 1 times the absolute value of A will equal the absolute value of A. But if the absolute value of A is more than 1, the absolute value of M is more than 1, and you multiply it by some positive number, it will be bigger than that positive number. 7 times the absolute value of negative 3 is greater than the absolute value of negative 3. I multiply this positive number on the left by more than 1. I get greater. If I multiply by 1, I'll get equal to. And the good thing is, that's all we wanted to show. We wanted to show that the absolute value of B was greater than the absolute value of A. Now, the next one is very important. And once again, it just comes from the definition. Nothing really magical. It says that if A divides B and A also divides C, then A divides bx plus cy for any xy in the integers. Okay, well, definitions. A divides B implies that B is an integer multiple of A. And A divides C implies that C is an integer multiple of a. But I don't want b and c. I want bx and cy. Okay, I'll multiply both sides by x here. So bx is ma times x, which is the same as mx times a. Over here, I'll multiply both sides by y. So cy is nay, which is n times y times a. Now if I add these two, I get bx plus cy is equal to this plus that. But I hope it's clear that there's an a in common that we can factor out. So we get mx plus ny times a. This here is an integer multiple of a. That implies a divides bx plus cy. If you like videos like this, where we prove theorems, every day there's a new video where I prove a new set of theorems or just one big theorem. If you enjoy that, this is the channel that you should most definitely subscribe to. Once again, every day I'm going to post a new proof of some theorems or a group of facts like I did today. Please leave a comment. Again, subscribe to my channel. And always, most of all, watch and learn. See you guys in the next video. Thank you.